Are we not gonna sing?
All right, we're live.
Hello.
So let's maybe give 2 minutes for people to join, and I think that it will probably get posted on. Yep, it's posted on Twitter so people can like.
So I can see it.
Join.
It's online now.
Yep. Yeah, let's give maybe another minute before people join. Oh, there's already 5 people on the stream. 6. All right, people are joining around. Cool. Let's give it another 30 minutes. You're in Medellin now, right?
Right.
Yeah, that's why we are doing this at this time, because it's like my finish of the day and Marian's start of the day between Medellin and Slovenia. Well, Ljubljana, if you're comparing cities.
Covering 2 time zones, like ideal for Europe and Americas, unfortunately not for Asia.
I guess that unfortunately cannot cover the whole world, but for Asia it's quite early. Quite late. All right, let's start. I mean, the rest of people can watch the stream anyway, so.
Sure.
Yeah, so with Marian, we've been, I think we've met at the Ocean Sprint. Yeah, Jacek introduced you to the Ocean Sprint. And we've been hacking on Nix and Rust and all different bits in different sprints. Also at the Tiger Sprint in Thailand, which is another sprint like gathered around Nix people hacking on different stuff. So we've been talking to like explore a bit of Twix and go through how Twix works. For those that don't know, Twix is re-implementing Nix in Rust and starting from scratch and trying to like take all the knowledge from so far of what Nix is and isn't and could be and shouldn't be, and trying to make another iteration of that. And like for me personally, I would like to understand how evaluator works, because there's going to be some experiments that I want to do and see how complete it is. And just like, yeah, that should also be one of the most oldest parts of the Twix code base, and also probably one of the most complex and those that need more work and contributions from other people. Yeah, I don't know, Mari, if there's something I said wrong or missed out, let me know. I don't know if you want to add
everything
something.
Is right. We met at the Ocean Sprint. I got introduced to Nix by Jacek. And I can highly recommend these events, by the way, the Ocean Sprint and the Tiger Sprint. If you want to learn more about Nix, get more involved into the community. Awesome people. It's really fun. It's like the programmer's dream. It's sunny outside, you're hacking the whole day, and then you have the chance to talk to awesome people about your project and tech and stuff. Yeah. And for me personally, my interest into Twix is like right now I finished my last project. So in between 2 jobs, I figured I don't want to waste my time. I've been in the past, I've been studying the PhD thesis from Elko, which also covers a lot of details on how Nix works, but I've never looked into the C++ code too deep and how it works and how it's architected. And in the last year, I've been switching to Rust. And since I've been in touch with Flowkey through these Tiger Sprint and Ocean Sprint events, I thought like, it might be a good idea to look into Twix and maybe also contribute in the future. Yeah, so that's why I would like to take a closer look.
Nice. Yeah, I think maybe worth mentioning is that Twix started in quite a while ago, and let me check because
in 2022, I think, is the first.
Yeah, December 2021. So
it started during COVID, if I remember Florian's story correctly, in Egypt. Yeah.
exactly. So it was mostly Florian and Tajin that met in yeah, that also got like the funding from NLNet Foundation and so on. Anyway, lots of details to that story, but let's try to dive into the code because I think it's good to get hands on. So just a disclaimer: none of us has done any work with the Tweaks evaluator, and since we did this quite ad hoc, none of the Tweaks people who did work are here with us. So we're going to be exploring this on our own, and then hopefully maybe next time more people can join. And maybe explain things that are confusing to us or correct us and so on. So
Right.
let's.
That's an important disclaimer. Like, we're not involved in the development yet. It should just serves like kind of pair programming, digging through the code, right, and trying to understand it, trying to understand Nix better. That's right. Well, yeah.
That's perfect. So let's. So this is my. I think we're gonna start with my editor, and then we can switch over to your screen. And yeah, I think that you've built the docs. So
Right.
we can also go through the docs. But I was thinking maybe just to go around and open some files and see what happens. And so I've checked out the tweaks, and there's like an eval folder. There's a bunch of other. So
Oh,
tweaks has this idea of splitting like nicks into different components that can be kind of used independently. Did you want to say something?
I just wanted to. I'm gonna post the link to the repository, so people know where to go to clone it. But I guess on Twix.dev you get all the information too, just in case. Sorry for interrupting.
No, it's good. So like the README says a bit about like disclaimers that it implements Nix 2.3. This is before flakes were introduced, so it doesn't have any flake like functionality. Although I think that's not entirely true anymore because there are things that are being added that were indeed added later, but more like the building blocks. Yeah, and it's like written in Rust, so you can just build it. And then there's like a bunch of nodes on like tests and the Arnix parser. So Arnix parser is like the underlying parser that is used by the evaluator, and that's like a separate component. Um, and I've read through these test bits, and it basically says that there are like three different suits, and essentially it has like its own set of tests, um, like unit tests and functional tests, and then it also includes the Nix test, which is the actual Nix implementation. And actually, fun fact, some Twix tests actually caught a bunch of like Nix. Well, I think we should refer to CNix just to be clear, because Nix now becomes um, like a
A
generic
standard.
reference standard, and I mean in my eyes, and then CNix, C++ Nix is the current implementation, and then Twix is the Rust implementation. Um, so yeah, like there's a bunch of additional tests, and then there's like Nix Oracle, which is actually evaluates expressions in Twix and compares the result with the C++ implementation. So one of
Basically,
the Mhm,
a regression test suite here to
mhm.
where the store and derivation part, like the store derivation paths and out paths are compared, right, to what Nix evaluates.
Oh,
Is it-
so I don't know. Okay, build just a bunch of printing. So if you build it, there's nothing special. There's like there's a bit of benchmarks, evaluating very basic stuff. There are macros. Maybe we can look at those later. Um, and then there's like the source, which is apparently very I cannot. I don't know how to increase. I'm using the Z
Just
editor. No idea how to increase, but I guess I'll just read it. So I don't know where to really start. There's like, maybe we should start in lib. This is usually the top level module that exports everything. There's like a bunch of modules that it exports, but there's also a bunch of code. So it exports, let's see, standard IO. Yeah, there's like a builder built-ins, builder globals, but I guess this is all part of the evaluation builder.
may I ask where you are right now? I'm sorry.
I'm in the
So
source
we're
in
in
lib.
the tree.
Yeah, I'm eval source lib. I think this is like the top level of the crate that you would like see in the docs.
Right.
Um, and I think this evaluation builder is like the as high level as it gets right now, to like essentially evaluating next, right? And here you have builder method or new method, builder pure or new pure, and builder impure. So like those kind of like give you the same defaults based on which kind of evaluation you would like to do. And we can go into the impure pure. I don't like this impure pure terminology as much because I feel there's different versions of impure and consequently different versions of pure. So I really hope one day we can come up with better terminology. And I even think that inside Twix, there's like different ways to do that. So like anyway, and by tweaking things here, actually you can, or like for example, you can set Nix path, right? So if you set Nix path that is already impure, in the strict definition, there's also strict flag, which I think is the pure versus impure setting, and then you can disable imports. There's like an IO type. I think that this type controls all file system operations, which is quite nice. There's like the environment that you can modify. There's like the globals that you would ship. I think, well, yeah, globals are here. So you have like different built-ins and then like a map of global variables that you can like expose. And there is like source map, no idea what's that. I assume threshold source code and Twix evaluation for accurate error reporting. Okay, so this is like some kind of mapping to understand where the imports came from, I suppose, so that the errors can report that. And then we have compiler observer, runtime observer. I assume these two allow you to like essentially call different methods when something happens, and then you can like do stuff when that happens, right? Again, this is assumption at this stage. Haven't looked through the code. I don't know. What do you think so far? Should we go through this file just like as a high level and see how?
Well, you dived pretty quickly into the code. What I just want, I don't know, like I don't know who's listening or who's watching, but to give people like so if you want to go get into Twix yourself, like I can highly recommend start with the blog posts that were written in the on the TVL on the TVL blog, to get an overview. And I like if you yourself want to get deeper into the Twix code, I guess it's a good idea to read the PhD thesis from Elko, because it covers a lot of implementation details and like, you know, the different components, the store, the evaluator, the builder, and stuff like that. Because this is basically how Twix is structured. So I just wanted to mention that, and where to go from now. Like as you mentioned earlier, I've been building the evaluator docs. Maybe we should go through through the official docs here first before we go to the code, or what do you think?
Yeah, we can do that. Maybe you can take over then the screen. Wait, let me switch over to your. I'm gonna do the switch to your desktop. And you can open the docs, I guess.
Sure. So
All right.
just a disclaimer,
Slide.
I've been only, excuse me?
Oh, no. Go on.
Okay. Just as a small disclaimer, I've been only building the docs and serve them locally here, so I haven't really read through them, and Domen, like, I don't know,
Same.
you may want to interrupt me, or yeah, just feel free to interrupt me while I go through this, like, but I guess let's start with the introduction first here real quick. Yeah, Twix is a new Rust implementation of the components of the Nix package manager. That's already what we know. Do you think it makes sense to go through the text, like, or should we just right ahead jump to the evaluator?
I think it would be good. Like, my first goal is to understand high level what components the evaluator like has and how they fit together. And then from that point on, like, we can go into one of them. Maybe that's like interesting or confusing or whatever sparks the interests.
Okay. Yeah, I mean, then from the outline, I can see here, like, basically what I mentioned earlier, what you'll get when you read the PhD thesis, you'll get a good understanding of how Nix actually works and what the components are, and here most prominently the evaluator, the store, and the builder, kind of the core three things. And so, yeah, I don't know, let's go to the evaluator. Compilation of bindings. Compilation of bindings is one of the most mind-bending parts of Nix evaluation. The implementation of just the compilation is currently almost 1,000 lines of code, excluding the various insane test cases we dreamt up for it. Okay, what is a binding? That would have been my question. Well, actually not, like a let binding, I guess. In short, any attribute set or let expression. Twix currently does not treat formals and function parameters. For example, what does he mean with formals here? I don't understand fully. Does he mean the defaults here, or?
I think it wants to say that, like, you that when you have like a function arguments, that it doesn't treat them the same as the binding. So, like, it doesn't bind that to the local scope or whatever the terminology is, I would assume. And these function parameters are like just things that get passed in, so that it's implemented in a different way.
I see. Okay.
Yeah, you see in this the next section, like, why that's not the case.
They have two very difficult features. Keys can mutually refer to each other in recursive sets or let bindings, including out of definition order. Attribute sets can be nested, and parts of one attribute set can be defined in multiple separate bindings. Okay, Twix resolves as much of this logic statically at compile time as possible, but the procedure is quite complicated. Okay. Yeah. The high-level concept. Do you want to say something?
No, I just started to think about, like, that. Yeah, I can see why this is complicated. And also, I remember when they were implementing this, I think that Twix has really good test suites because they were trying to cover, obviously, all the edge cases when in re-implementing to make sure that these edge cases behave exactly the same as they do in the CNIX. But yeah, sorry, go on.
All right. High-level concept. The idea behind the way we compile bindings is to fully resolve nesting statically and use the usual mechanism like recursions, funking, value capturing for resolving dynamic values. This is done by compiling bindings in several phases. An initial compilation phase only for plain inherit statements, okay, not for namespace inherits. A declaration only phase in which we use the compiler scope tracking logic to calculate the physical runtime stack indices, further referred to as stack slots or as slots that all values will end up in. Okay. In this phase, whenever we encounter a nested attribute set, it is merged into a custom data structure that acts like a syntactic abstract syntax tree node. This can be imagined similar to a rewrite like this. So, okay, so it's basically just expanding attribute sets. The rewrite applies to attribute sets and let bindings alike. At the end of this phase, we know the stack slots of all namespaces for inheriting from all values inherited from them and all values and optionally keys of bindings at the current level. Only statically known keys are actually merged, so dynamic keys that conflict will lead to a key already defined error at runtime. And further, a compilation phase in which all values and when necessary keys are actually compiled. In this phase, the custom data structure used for merging is encountered when compiling values. As this data structure acts like an abstract syntax tree node, the process begins recursively for each nested attribute set. At the end of this process, we have bytecode that leaves the required values and optional keys on the stack. In the case of attribute sets, a final operation is emitted that constructs the actual attribute set structure at runtime. For let bindings, a final operation is emitted that removes these locals from the stack when the scope ends. Okay. Do you want to summarize this or?
I've been talking, being muted. It's interesting because one of the optimizations that I would really like to see implemented is something that in Haskell is called floating the lets out. So like imagine if you have like a loop where the let binding is not like is basically in Nix it's always recalculated. So for example, I had like I've built like software where it builds a matrix of different options. So imagine you're building some software and then you want to test this for different kernel version, for different compiler version. Then you loop through all the kernels, you loop all through the compiler versions and so on. So then you get like more of these variables you have, like obviously it's exponential. But then Nix wasn't smart enough to, for example, float out the kernel. So like if it's, so like depending on where you use it in the loop, you can like not allocate that every time you go through it. So I don't know how Twix handles that, but that's definitely something that, especially if you import Nix packages or something like this multiple times, that should be like floated out if it's not referenced. Anyway, that's more of an optimization phase, but we'll get to that part. But this is just trying to explain how the whole binding, like different phases happen. I think this is like interesting from a high level, but I wouldn't go into like the details of like if somebody wants to know how exactly it all works. I think this is the document where, and then this is where the things should be added if they need to be explained more or something like this. What is at the bottom? You have like moving parts.
You mean here, the moving parts here? There are a few types involved: peekable attributes, peekable iterator over an attribute path, for example, a.b.c. Bindings kind enum, defining the kind of bindings. If it's an attribute, set, recursive attribute set, or a let binding. Then the attribute set, which is the struct holding the bindings kind. The abstract syntax tree nodes with inherits, both namespace and not. Okay. And an internal representation of bindings, essentially a vector of tuples of the pickable attributes and the expression to compile for the value. Okay. Binding, enum describing the kind of binding, whether it's a namespace inherit, an attribute set, a plain binding, or any other value type. Then we got a key slot. It's an enum describing the location in which a key slot is placed at runtime. Nowhere statically known value in the slot.
Flockley's joined us. Hey, Flockley.
Is he?
Oh, I need to add him. Hey.
Hey, can you hear me?
Yeah.
Nice. Yes.
Okay, this works. Nice.
Nice.
Awesome.
Cool. So Flockley, well, I guess you can introduce yourself. It will be more precise.
Yeah, I mean, I've been spending some time on Tvix, less the evaluator parts, more the store and builder components. But yeah, I'm happy to answer some general questions if you have them. Overall, I did some digging into the evaluator, but it's not my core thing that I keep doing all the time. But yeah, no. If you have any questions on how you want to put things in perspective, yeah, I'm here.
Nice. So one of the, sorry, Mike, go on.
Well, my first question would have been like, what we're doing right now feels kind of tedious. Like I feel like people can go through the docs themselves actually and read it out. So my question would be, what do you think where we should get started? But Domen, if you have another question, that's kind of.
Oh, I think that's good.
Before or after.
Yeah, compilation of bindings. Yeah, that's a very interesting thing. Like you have, I think, 3 different stages of how things are merged and different orders. Like if you have an attribute set and it has regular keys where you say A equals something, or if you say like or instead of A, the string A, you have something that has an inner like a dollar curly braces and then an expression there, and it might result in A. That like happens at the later stage. So they have different orders in which they merge and different priorities, and that's all very mind-boggling because it's not really specified anywhere. It just happens to have come up with the semantics because some of the things that oh, that's my cable. Because some of the things that are dealt with in the lexer in X, and that's just why it deals with some of the stuff earlier than others, and that's why these semantics came into place. So yeah, this is kind of like explaining our implementation of it, our understanding of it, our infrastructure around it, and we have a bunch of tests that kind of ensure that the behavior is consistent with Nix, and that we properly understood all the niche and corner cases.
Nice.
Yeah.
Yeah. One of the interesting
but this
things.
This is all semantics, and then we have like overall we have this structure where we parse the source code. We create the AST, and then from there we emit bytecode, and then we execute this bytecode. And then, so part of the logic that is explained here is like, well, ideally, most of it only happens after we, like when we at the AST or when we're done executing the bytecode. But sometimes things are split between like, this is something you do while you construct the AST, and this is something you do. This kind of explains how you structured certain operations in the VM that interprets the code. And if you're talking about doing optimizations, then it also becomes a question: do you want to do this? Is this something you can do at the time of constructing the AST, or is this something you can only do at runtime because you know the specific value has happened, or you did this specific dance with these specific values a sufficiently large number of times, so it makes sense to kind of optimize it differently or have a specialization for that. But that's kind of a bit after that. So these docs more like describe like our findings on semantics on the Nix language and how we dealt with it in Twix in general. Less so much where things are.
Can you explain a bit more why you're using bytecode and how does that compare to like the Nix?
Yeah. So Nix parses. It's kind of it descends. It descends the source code in like the structural in a structural way. So if you have a specific piece of Nix code and there is a function called there, then Nix executes a certain function and kind of goes deeper in its own stack frame, and then it parses this file, runs the same functions there, and it kind of so like your call stack becomes a bit
C
like
call
the
stack.
Yeah, your C code stack becomes a bit like how deep you are inside the Nix code. Whereas in Twix, we're saying like, okay, we're gonna parse as much as we can, or like we're gonna parse the current file we're at. We're gonna produce the AST, gonna produce the bytecode, and then we have the separate thing that executes the bytecode. And because that's similar to how LLVM or kind of deals with how compilers try to deal with this stuff. It's like you can have a specific, you can have different phases and you can do certain optimizations in different phases. And then if you can kind of transform a specific type of expression into a standardized thing, and then you might have the same optimization phase. You might be able to do this generically on more input expressions, essentially. We do some of these optimizations where we have like, I don't know, where we can statically determine that like a conditional check is always false. We don't even emit this, but there's obviously more optimization potential. For now, it's more like, okay, how do we? So kind of the way this is structured like this makes it easier to do these kind of optimizations because you have this nicer split between different things, and it long term is also going to allow you to like, oh, I'm just going to store this bytecode somewhere here in some cache or whatever, and then I'm gonna run this bytecode. If I encounter this piece of code here again, I know I already did all these transformations, so maybe I can cache them. Maybe I can even put them on disk for the next run and get like evaluation caching or something, or at least speed up. Whereas with Nix, it's always like, oh yeah, I'm gonna parse this text file again, and I'm gonna keep digging deeper in my stack. So that's kind of the thought process behind why we have a process that takes the code, and the AST produces bytecode and then executes this bytecode on a virtual VM that understands certain Nix instructions. Maybe we can open the Rust docs for the expression. I think operation is what it's called these days. Opcode or operation.
I have the source open here, but I can also share your screen if you want to share yours.
You can just go to
Opcode?
Tvix.dev, I think.
Tvix.dev.
Yeah, and then it should link you to the Twix evaluator Rust docs, like Twix eval create Rust docs. And then you have an enum called op in opcode.
In opcode. Oh, maybe I can just go in opcode. And find it here. Ah, there it is.
Yes, there you go. Like go further up. Up. There you go. Op represents all instructions in the Twix abstract machine.
So I want to like, for me personally, this bytecode design is the most interesting one because when you look at any Nix code, right, you're going to import Nix packages at some point. Like, unless it's like you're playing around or whatever, but if you're building anything, which is what Nix is for, you're gonna evaluate Nix packages. So like, caching that part is like 99% of the work usually, because like usually you're gonna have like a bunch of glue code that takes Nix packages, does something with it, and then like builds that or whatever, right?
Yes.
So like caching all those bits seems like very sane to me, and that's something that why I'm interested, because even if Twix evaluator would be slower, which currently it is, than C++ Nix, and we can talk about the performance optimizations which haven't been done as far as I know, to even get there and to match the C++ Nix implementation. Like, just even if you skip that part and you just do like, storing bytecode to disk, probably you can get a lot of the value from like maybe an expensive initial call to get the bytecode, but then things should be much faster. How faster, we don't know yet, right? But that's the idea.
Yeah, there's generally different strategies to go with all this. And what's your strategy on understanding that this is something you do sufficiently often to come to kind of to be willing to expense the cost of transforming it into a more machine like a more machine near format? I mean, we do this transformation to bytecode. We don't do the interpreting part that Nix does. So we always go to the bytecode. But there is some optimizations you can do. If you look at other programming languages that also use abstract virtual machines under the hood, like Java or something, or the Node.js V8 engine, like if you encounter a certain path and you spend a lot of time in this specific part of the machine and running these instructions, it might be worth to kind of rewrite this into, like, compile this into a more machine more optimized fashion, more optimized variant, which is what hotspot like jitting, just-in-time compilation is. And you can do this stuff. You can also say like, oh, I'm just gonna dump all the bytecode that I have on disk, and then gonna have a small database that is gonna check the hash over the source code file, and then it's gonna find the bytecode or something. There's some things where you have to be careful about, because like different Nix source code might mean different things if they are in different directories. So just the hash of the file cannot be your only lookup thing. But there's like different strategies to do this. But the point is, we have these options to do this kind of stuff with this architecture. And if we get the basic concepts without the optimizations right, we can slowly start adding those, can validate that they still behave the same, and can like also do some benchmarking on in which cases does it make sense to actually go this optimization route, or does it make sense to go on this optimization route with a very nice data set, which Nix packages is, right? And just say like, okay, I'm going to evaluate this, like all the Nixos VM tests that we have in Nix packages, and if I specify this specific optimization here, what's the difference in eval speed for that? Which gives you a pretty good real-world, yeah.
That's really nice.
Thing to time.
So just to be clear, what is the boundary for this, like transformation into the bytecode? Is it like at a file? Given that you said you can do that, I don't know how exactly that works.
Yeah, we have this Twix bolt. So there's a concept of like stacks. That's not really my area of expertise, but we have different. Let me just equals 10 equals n plus n. Five. Okay. And interesting. This is a bug. But yeah, there's different layers of granularity you can use to decide what you want to cache. Like maybe it makes sense to like have an optimized version of your Nix packages thing. You just do like, okay, like we have this all our channels. Maybe we can do some upfront compilation there. Maybe there's like realize on the function boundary, like, oh yeah, call package is used quite often, maybe we can get 1 or 2 specialization for this, or like maybe I don't know, this specific package expression with this specific set of arguments is used quite often. Maybe we can have a representation for this. Yeah, there's different layers of granularity which we can do, but the whole point is if we start with something, if we start with this architecture, we can make informed decisions about what brings speed up. Yeah,
I find it really cool because I think I've said this before, that Nix is like the DevOps language of, like, the JavaScript equivalent of the DevOps world, and now we're going towards like JIT and all that, so it really feels like that. I mean, and the similarity is mostly between that nobody really likes the language as much, but there's so much stuff written in it that it doesn't make sense to do things on that front. But
well,
no, go on.
I mean, I would say, like, yes, no, the people don't like the language, or like there has been some annoying decisions made in the language, or like some oversights that result in certain annoyances that are now hard to change. And yes, there's a shit ton of stuff written in Nix, but I'm saying there could be a path where we like have another front-end language, because we have this nice separation between, like, oh, we have something that creates an AST, and then we have something that creates bytecode. Now, what if we have some other things that also produce the front part, right? Like LLVM also has different front ends for different front-end languages, and then emits some intermediate representation that is independent of the source language mostly. But yeah, the thing is, in this whole system, in this whole ball of wool, we still need to be able to understand and interpret Nix, and we need to understand and interpret it with the same semantics as the existing Nix C++ implementation. So Nix packages works, and everything kind of is usable. If we don't have this, there is no point in thinking of, like, oh wow, what if we can design another language that allows us to use this? Well, if we don't have those components, we need to end up using a Nix C++ evaluator under the hood, and then everything is going to be like much more complicated to integrate. So get the semantics first, and then gradually see how you can optimize things, how you can add other things, how you can do things slightly different. There's also a bit of a layered approach. It's not really visible from the evaluator alone, but the evaluator alone doesn't have knowledge over certain aspects of Nix. Like, it doesn't know about what the derivation is. It doesn't know what you do when you're building something. It unfortunately knows about string context because for other reasons, but there's a lot of things that the evaluator itself doesn't know about because it's not the core part of the language. But it's just like there happens to be a built-in that does this as a side effect, but it's not really observable from the inside of the Nix. Or well, for someone who's just a machine executing bytecode, and someone else tells him what to do when encountering a certain piece of bytecode. So in the Twix CLI crate, you kind of use the Twix evaluator as a library. You pass in a bunch of other built-ins that are not part of Twix eval core, but instead they are part of Twix glue, and that thing knows what it is to build things. The evaluator itself is not aware of what a derivation is. The evaluator itself just knows, oh, I have built-ins I can execute. I can parse Nix code if it follows certain syntactical rules, and I emit bytecode, and that's what it does. So we have a very pluggable thing. That's why we have this WebAssembly demo that runs a subset of Nix languages, right? It doesn't know how to build derivations because it doesn't have a CPU with a good instruction set and a Linux syscall interface, right? But it still uses the same logic to interpret Nix language. Sorry, I kind of
No, that's really good.
Yeah,
I mean,
it's great.
I think it's really good. Like, there's a lot to cover, and I like that it's like just as an island of information, and then we can slowly make some sense out of it. I mean, we were before going. I guess this evaluation builder is like the library block, right, where you kind of like construct.
That's your builder pattern. That's what you use to kind of configure the evaluator thing, and then you call
build, I guess, or run.
So there's this builder. Do you somewhere see the list of functions? Like in the usually there's some symbols thing on. Yeah, here we go. Yeah, that's just too small. But you have add built-in here in the evaluation builder, and with this and with that, and then at some point you
new pure, for example.
Yeah, this
I
again
guess
gives you different.
That gets you. Yeah. Sorry, what were you saying? What's in there? What am I looking for? Builder.
I cannot read what's there. I would need to open this in my editor or something.
Let me try to increase.
I can open the Rust docs.
There is no.
It's fine.
Can you see it now?
Evaluation builder.
It's a bit bigger, but the tree is still small.
Yeah.
Let's make it bigger then.
Control Shift plus or Control plus.
There's no
zoom in.
Build is the name of the function. Just search for build.
Build.
Evaluation builder has a build thing, and that gives you an evaluation. Here you go. Go 10 lines up.
Oh yeah, that's why I wasn't seeing it.
Yeah.
All right.
So and this takes this builder pattern thing that has been configured with like, oh, you have these built-ins and you have this and whatnot, and then you can call build, and it gives you an evaluation object which you can then query for like
statins. Yeah. So that gives you evaluation thing. Okay.
Evaluation, and evaluation itself also has an evaluate thing, which then consumes self.
Oh, I see. So then you have evaluate. Oh, and there's also compile only, which I guess gives you the bytecode.
Use this for some linting purposes.
And evaluate is like the big thing that actually then gives you evaluation results, which is warnings, errors, and the value, and expressions. Nice.
Yes.
An expression. Okay, that makes quite a lot of sense to me. And errors are a vector and warnings. So one of the annoying bits in like CNX is that traces don't have source location. Is that something that I assume the traces go under warnings? I don't know. No idea.
So you have different types of like there's different systems for like tracing. One is so if you want to say like, oh, this variable here has been like you want to debug an infinite recursion or something across Nix packages, then yes, we know from each span that we open, we know the position, we know what argument it's being called with, and we can kind of give you a nice trace across the different parts of the source code that you look through, and then you see like, oh well, yeah, I made this silly mistake here. That's one thing, but that happens mostly after the fact as a reporting mechanism. Like you like source map is kind of nice because it doesn't need to store a lot of data, so it doesn't consume a lot of memory. It just needs like the offset in the file and the file name or something, and then you can kind of construct the nice formatting and reload the file contents from disk or whatever when you do the error reporting. So you don't need to store a lot of data for this. Then there's also tracing, as in the OpenTelemetry or logging kind of thing. So we use the tracing Rust crate that can emit trace events, which can be logs or which can be tracers. And we use this more actively for stuff that takes longer time. Like we don't use this to debug where Tvix.eval spends time. That's more like profiling. But we use it for like, oh yeah, we're talking to the store, and the store talks to this thing, and this thing then talks to this thing, and where do we spend time, and why do we spend all the time? This is kind of like another type of figuring out what's happening. And we have the compiler and runtime observers, which are just like objects that implement a certain trait and that then can get called if they have been if our evaluator has been configured with them. And you can use this to like, I wanna figure out whenever a built-in gets called, I want to check that the built-in has this specific name, and then I want to kind of print those specific parameters here. For these kind of use cases, you can use those observers. So these are the three different tracing implementations, quote unquote.
It is really nice. And then you have also the I/O. Yeah.
Yes.
Yeah.
So all interaction with the file system happens through this I/O handle. So Tvix.eval itself can run in an environment where it doesn't have a file system, like the WASM thing. And then there's different implementations for this. I'm not sure if you can right click and say like show implementations of I/O.
I don't know how you do that in Z, to be honest. But let's check.
Yeah, here's a trait.
Yeah, right click.
You're already right.
Right click. Okay, let's try.
Try right click.
Go to implementations. And it doesn't work.
And it doesn't work.
Maybe you don't have Rust Analyzer in your path for this thing. I don't know, but
maybe
I
just
you
run
were
shell,
in yeah. Okay.
In
Just
I/O,
go to
I guess.
IORS. This is part of the thing. Like this contains some this contains the trait itself, and it contains some implementations of it. It doesn't contain the thing that Tvix CLI uses, because again, this is using Tvix store, and Tvix.eval doesn't itself can be very thin and very small. It doesn't need to understand how to talk to the store. It just needs something that has this interface. So you see a dummy IO complains that it doesn't do I/O, and we have
That's really nice. So you have like dummy I/O, which just says, okay, this doesn't work. You have the actual I/O, which is like actually using the file system, but you could implement. I mean, this is really nice. For example, if you want to track, like what files did it need for the evaluation, right?
Yeah, if you wanna implement some like if you want to get an exact software bill of materials for all the Nix files that this thing reads, or all the other files on the file system that this thing reads, you can just instantiate your evaluator with an eval.io trait that explicitly tracks all these things and writes them into a file or whatever, and then then you get exact information for this stuff.
It's really nice. This is really nice for caching. If you like, I mean, the VM long term, I think the VM caching is obviously the way to go. But short term, you could use this to cache like the inputs.
Yeah, I mean, first I want to get the insight into where we spent the time, where we spent the time with most, and then once we know this, we can see where it makes sense to optimize, essentially. But yeah,
nice.
This being broken up into different things is making things easier. Yeah, these are the observer traits where you can say like, oh, I want to see when I enter the call frame. Then you can implement this function here, and then you can peek at the values and can do something. I don't know, print something on the console or whatever. Print something on your printer. Whatever you want, that's code.
So, okay, let's look at VM, right? That's, I assume VM mod. Okay, this module implements abstract virtual machine that runs. So this is like then the actual runner of the VM, right? It has a call frame.
These are the data structures that that make up the VM essentially.
Right. So, well, maybe we should start in a different way. So one of the things that I would really like to add is a debugger, like debugger functionality, whereas if you get like an error that you drop into a debugger. So I assume that would happen then at the VM side.
So I assume your debugger at some point wants people to be able to like step up and down. What you could right now do is like we don't have a way to kind of control control the execution of the VM. At least we don't have it right now. Where you could say like, oh yeah, I want to jump over this and I want to create and I want to jump back here or something. What you could do is you could use these observers to kind of implement breakpoints and then debug and print a lot of things to figure out what's going on and make this possible for individual stack frames and stuff. And then you could maybe resume execution, but recovering from an error and then replacing the bytecode with something else and then continuing to execute, that's kind of much more complicated. And you would also need to...
I think a read-only debugger is like already good. Like if I can build a read-only like inspecting debugger, I don't know, whatever you would call it, I think that would go a long way. You know, like that I could like list the local bindings, go up the frames, stuff like that.
I mean, we kind of have this already in Tvix.dev, right?
Sorry, what's Tvix.dev? This is the web thing.
Yes.
The web evaluator.
Yeah, so like I think that the read-only version of the debugger is fair enough. Because like usually, you know, because in Nix if you have relatively complicated code, you quickly run into, for example, like codes where you get an error that you cannot do operation between two types. That's a very, very typical one. And then you want to understand what are the two types and the values of them. So you know the types, right? Because usually you would get that in an error message, but you don't know the values, right? And how that happened. So that's something that I would like to then debug and try to understand, okay, what is the value of this thing that it actually happens, that this code executes in a certain way. So it's more like inspecting the state of the VM.
Did you open the? Can you open Tvix.dev?
Is that also here in the?
Just on a website, just type bolt.twix.dev.
No. I mean the source code of it. It's in Tvix.dev.
I see.
I'm not sure because I only have checked out the Twix. I guess Tvix.dev is a top level of the TVL.
Yeah, it's elsewhere. It's
yeah, I don't have that checked out.
No, but what it uses there's like a disassembling observer and tracing observer. Like a disassembling observer for the compiler observer and tracing observer for the runtime observer, and those are defined in eval because they are generally useful. So you go to Tvix eval observer disassembling observer.
Eval. Oh,
you're
this is
already in the right file, I think. You're already in the right file. No. The traits and these implementations are in Tvix eval because they're useful.
Oh, I see.
But Tvix.bolt is a consumer of it.
Oh, yeah. I see. Tracing observer. Okay. Yep.
Yeah, that's implemented for something where they can write into. And we use this to you can open the website maybe, and then you can the Tvix.bolt website, and then you see that that they have like how it works, what it shows you essentially.
Okay, maybe because I'm only sharing this window, maybe Marian, if you want to show the Twix bold, I'll add your screen.
Sure.
Yeah.
Oh, I see.
Yeah, maybe do a bit more of a like, I don't know, let A equals 5, or like an attribute set equals 5, B equals an attribute set which inherits A or whatever. We can dream up some code.
Yeah,
What
you need the
B?
body.
B equals an attribute set that inherits A. Semicolon, and then in B. Yeah, the unused variable tracking, there's something broken there, so we can ignore that. But here you see the bytecode that has been created, and you also see the trace of the execution. So all this info is there, right? I mean, that's not very pretty, and if someone is like capable of of making nice looking websites with fancy visualizations, then no. But I mean, there's all these websites that explain you how, I don't know, a MIPS instruction set works and how it mutates things inside different parts of the CPU, and like allowing people to explore what certain bytecodes do and what fields come along with them, and how they mutate over time. This would probably be a very nice way to visualize what's happening. Whereas this is very textual and maybe not so pretty.
Okay, so coming back to the debugger idea, I feel like the VM is like, it loses information like variable names and things like that. So you would have to, because like one of the main reasons for the debugger would be to say, okay, I want to see the list of variables and their values in the current scope, for example.
Yeah, I mean, you can construct this, and if you go back to scroll back a bit to the top, no, oh sorry, like to the warnings here, like it shows you context. You can probably jump into specific stacks as well and peek what variables are reachable from there. You might need to jump a bit around in the bytecode to figure it out. And ideally not cause side effects, because you're suddenly forcing a thunk. So we need to have a non-invasive peeking at something. But yeah, like I think this, I mean, this is not something we can quickly write today, but this is definitely something that the architecture would allow for.
All right. Cool. I don't know. What should we look into next? Marian, do you have some area of interest that you would like to see?
Well, right now, not like what. I'm just gonna go back to my first question, where I should. Well, I guess we did that. We took a look at the evaluator crate and the evaluation builder. Yeah, I don't have any things like I would just yeah. My goal was to get a better understanding on how the evaluator works, where I have to look at the code and yeah.
Yeah, I mean, the complicated part is a bit the split between the crates. I wanted to write some more documentation around that structure. I don't know if it ended up being submitted already, but yeah, like what kind of crates do we have and why are things in certain crates? You know, we have a YouTube video explaining it at the end of this, but yeah.
Exactly.
I should probably still write it down a bit more, but yeah.
There's also
yeah.
There's also the compile. I think we touched most of the source related to the evaluator. Just I think we skipped over the compiler. I assume that's where most of the like AST to bytecode stuff happens, right? I don't know. Like there's the built-ins where the built-ins are implemented. And there's VM where the VM runs, but the compiler is the one I assume that then gets you to.
Yeah, that adds the versus the AST, and adds instructions, like from this
Right.
hop enum that we saw before.
Marian, do you mind if I share my screen?
Yeah, take over. Feel free.
All right. So I see there's like an optimizer, which does, I think it only optimizes as far as I see, like
Very simple stuff, yeah.
very simple stuff. There's like a lot that can be later added here. But yeah, I guess this bindings is what we were researching before you came, which has like apparently almost 800 lines of code.
Yeah, this is all very like, it's good that this now works and that we have a ton of unit tests to be able to refactor it without accidentally breaking something. And it's good that the general like insights we got while doing this exercise are written down somewhere. But this is probably not something you wanna be constantly spending time with, because it's a very, I hope this is done. Let's put it like this. I hope it's done. It's a very insane part of the language.
Never gonna go back.
Yeah.
Yeah, I remember I wrote when I wrote like the empty patterns for Nix that are now a part of Nix.dev. Like I was really trying to like remove things. Well, advise not to use things from the language that require that doesn't allow you to do static analysis stuff, right? Like rec is a typical like thing that complicates the reasoning of what is happening with the bindings quite a bit. And width and rec are the two things that I think shouldn't be used if you want to reason about what your bindings are in the file.
Who is you in this case?
Well, I wrote the empty patterns for Nix.dev, and as far as I know, they are still there.
No, I mean, where you cannot reason about the value of something because.
Well, I mean, like the rules around width, for example, like chaining width statements in Nix is very, very strange.
Yeah.
So like I would assume that most people wrongly assume what is their bindings that like if you say with an attribute set and with another attribute set, the rules around that are like probably most people get the wrong impression what's happening, and you know, when the bindings get shadowed and stuff like that, you can quickly make mistakes. So I generally tell people to avoid these like dynamic scope things as much as possible.
We have some interesting test cases for all this stuff. It's
yeah, exactly.
It's a very specific part of fun.
Going back to the previous conversation, like, you know, we could have Nix the good parts where like you remove some of that stuff. Like could be a flag to Twix where you say, okay, this I don't know, disallow weird stuff, or tweaks the good parts, I don't know, whatever. And a lot of this goes away.
Yeah, I mean this is like, I always keep saying Twix is a re-implementation, not a rewrite. A lot of the things are like designed with a different underlying architecture, using a lot of composable layers that describe certain aspects and pull them in from like a helper library that kind of takes care of that specific aspect. And if at some day you decide like, oh well, I don't need to come up with exactly the same store path names anymore because I don't need to be compatible with cachenix.org and the signatures and whatnot, and I'm confident that I in generally still have the same behavior, then yes, you can pop some of these layers and remove a bunch of functionality, do some calculations maybe differently because it's more efficient, or there's like better ways to do this. But yeah, first you need to properly capture all the semantics and have them exactly the same, and then you can decide like, oh well, what if I combine these different layers slightly different, or like strip one or two and drop this one built in here because it's stupid or whatever. Yeah. For example, it's super trivial to add another built-in to the evaluator. Like if we go to some of the built-ins that are defined, like some of them are really, really small, and it's super easy for someone to add a new built-in. It's just all the simple ones are already done. So
I guess here.
Yeah.
Oh yeah, there's like a macro.
Built-ins.
Yeah, we have a macro because we there's some stuff going on when you interact with the VM and you want to force something, and that might do other stuff. And for this reason, you need to kind of pass messages around. But and that's why we have this macro. It sets up a bunch of things and makes it more concise. But yeah, there's also what this whole generators thing is about.
And it's all async Rust. Interesting.
It's async in Twix is an interesting question. This is not async as in the Tokyo async, but we abuse the Rust async machinery and state machine creation machinery whenever you have an await point to create individual pieces that we can then we use this for tail call optimization stuff. This is not an async function in the Tokyo sense. This is an async function that.
So wait.
So you get a future or what? And what do you do with that future? I don't
know. This is kind of to schedule execution with this. No, not to schedule execution. To break at certain point where we run other code and then go back here and kind of lay out this thing. It's not like async futures and Tokyo takes care of scheduling. We have Tokyo in other places, but we don't have them in the Twix evaluator crate. The Twix evaluator crate only uses the async keyword and the async machinery to use this generator this generator pattern. There's a documentation about this in that describes this whole machinery, but that's like a video on its own.
Can you just tell us
docs for
which file?
VM loop.
Oh, okay.
VM loop. You need to
we haven't touched the value which
no VM loop as in the docs.
Oh yeah, I remember. Maybe Marian.
This is like
here. Okay.
Yeah.
Yeah. That's it.
Okay.
I think to make this, to cut this a bit short, we have async here for whenever we want to talk to the VM and trigger something that can force other things. But we don't have a Tokyo scheduler or something there. It's just to break things apart into smaller, like into a state machine, and to be able to resume there.
Okay, that's interesting. Like, okay, but I don't know if you know enough about evaluator, but like one of the interesting bits would be like, let's say you have an attribute set and you want to like use Tokyo or whatever runtime, then to evaluate those attributes in parallel.
Yes.
Like, and would that async be conflict with existing ones, or I don't know how that all works together then.
So it's not yet clear on what the exact architecture for this should look like, because you might have dependencies between different parts of execution. Let's say these all end up waiting on a specific thing that both are then blocked on, and then you cannot do much except waiting for this. What this async part is only doing is like, oh, I create, I kind of, this allows me to break code into smaller things. Every time you have an await in Rust code, whenever you have an await between something, it kind of splits the code into different slices containing this code and has a state machine to track in which state it is. And then kind of the Tokyo runtime can execute this, and then the next slice it can wait an indefinite amount of time and send it elsewhere and execute it there maybe. And we use this machinery to schedule the interpretation of the bytecode inside the VM. That's where we use the async machinery. If we say we want to execute things in parallel, we could be using the Tokyo runtime. We could be using just one thread per core and just have another mechanism. There's like different things, and for these we also need benchmarks and observability into what's a good design. For now, that part is kind of, think of it as it is entirely sync right now. We just use the async machinery to like jump elsewhere and do something else until we get.
Yeah, that makes sense. So that's like completely open for future implementation. How the scheduling between different threads will work.
But, it is totally possible that we're gonna be using Tokyo there at some point if it makes sense, or something lighter where we are all running a local like a local, how do you call that, local task set or whatever. So we stay on the same CPU and stuff doesn't need to be like
moved around
sync and moved around. But this is all up to further exploration. Where we have async is in the store things where we actually do I/O, or where we send a network request and we wait a longer time for something. Like there's definitely, let's say we're ingesting a store path. We can read multiple files in parallel. We can read multiple positions in a file in parallel, depending on the hash function. We can do a lot of things there in parallel where we don't have to like wait until we hear back for this specific thing. And there we use async. At the bridge, we right now have a sync trait. So the eval.io trait that we saw is sync. But in most, like in the Tvix.dev implementations, it tells Tokyo like, hey, please block on this here. So we give a sync view over a bunch of async stuff that might happen concurrently or in parallel in the store side of things.
Nice. So I'm gonna need to go in 15 minutes. I don't know if maybe if people have some questions, we can dive into those, or I don't know if locally you think there is like part of the evaluator that really needs to be explained on top of what we just talked about. I think we covered quite a bit. But I don't know if people have any questions. We have 103 people on the live stream right now. I think this spans between YouTube and X or Twitter, whatever. I mean, I'm not sure if people can comment on X, but definitely on YouTube. Anyway, if we get some questions, I don't know if we should. Oh yeah, here's a list of all the built-ins that are implemented and those that should be implemented.
Break.
This may be interesting. There's whole discussion around Tvix doesn't do flakes or something. Well, flakes are not a language feature per se. Like the evaluator, it's the core Nix language behavior. The way you have a bunch of Nix code that looks like this, and you run built-ins and stuff. This like looks the same whether it's flakes or not. There's like one or two built-ins that exists if you have flakes enabled, and all the rest is like CLI frontend, different CLI tools that you can use to manage different files. Yes, there's like one or two different semantics with what is allowed in a flake.nix file, but other than that, there's like nothing in Tvix eval that really needs to understand what flakes are, and that's why we're like not focusing on this right now, but first getting the existing behavior that we have in Nix packages done, because we don't need to implement any of these initially.
So one
Yeah,
basically just needs to implement a Flake front end for Twix, and there you go.
Yeah, I mean, we don't have a front end for like end users
Twix.
in Twix
Yeah.
right now. It's a library. We have this Twix CLI thing that we can use to trigger a bunch of things. But as the documentation says in the main thing, it's mostly right now a bunch of components that people can use, and it might solve your use case. It might solve almost your use case if you add these 1 or 2 different additional things to it. But it's not like we don't need to implement the entire CLI surface that Nix has right now, because we don't need to be a Nix replacement yet. It's more like, let's get the basics right. Let's make sure we have the semantics exactly the same. We're not fully there yet. We're super far. Let's get all this functionality done. Let's make it fast, and then let's see how we add a UI, and then maybe a UI that behaves the same way as Nix to some extent can be in another crate that just uses all this library code. And then maybe we have another CLI that has like a nicer UI, more understandable UI, whatever. Anyone can write their own CLI for Surface for this. This is all future work.
And what maybe people wanna, let's say somebody's super excited and wants this to happen. What are the bits of the evaluator that you think still need the semantics?
There's some things on context propagation and on error handling, and what errors are catchable and what not, which even changes across Nix versions, but sometimes is observable in Nix packages, which is deeply terrifying, but the way it is. We need to get all these semantics right, and there's work on having something that evaluates Nix packages and compares it with Nix, so we see, oh, where are we differing? And then like there's a lot of staring at traces, or maybe someone finds the time to write a proper tool to kind of graphically explore the differences and highlight, like, this is from where it starts to digress, and this was kind of the surrounding thing, and we're gonna take this error and we kind of computate it into all the descendants, and then we diff further, and then we see another thing to kind of really make it easier to spot out these differences. Like, if people are willing to spend some time helping with that, it would be greatly appreciated, because the closer, the sooner we are with being functionally equivalent, the less insecure it becomes that all the overall architecture we made so far is doesn't need longer extension or anything.
And the bugs that you mentioned, are they like in the bug tracker, or is that something that still needs to be like explored? I guess
I need to. There's to-dos here. There's some to-dos, but that's mostly to-dos that I encountered while working on Store and Builder. There's also a lot of interesting stuff there, but I think showing up in the Tvix.dev IRC channel and asking is helpful. I'm gonna try to brush up some of the docs until NixCon, so it gets easier to understand and get started. But yeah, usually people come with like, oh, I have this very weird Nix use case. I wanna evaluate Nix expressions on my toaster, and I need this specific built-in for it. And then we help people with this specific thing, and then they're gonna run into 1 or 2 bugs while going there, and they fix these. That's usually how it works. Yeah.
Cool. Nice. Yeah, I think that's a good start. I think that probably starting with, I know there is a, well, not pull request, but review requests for Twix eval jobs, which would then allow us like to compare, let's say, how Nix packages evaluates, which I think is like one of the most important bits.
Well, that's
that
one
really
part
needs
of
to work.
the equation, right? That's the thing
Yeah.
that just takes care of descending into attribute sets the way Hydra does.
Yeah.
For this, we need to have machinery to kind of control the behavior of descending inside the evaluator, control a bit of control flow. And then there's all this thing of like, okay, now we found the difference. How do we avoid having to stare an hour at certain things to spot out the difference? And how do we write tooling to make all this more debuggable, easier and debuggable? And this is all. This is also like a large field where we could use help.
Okay. So like the debugging tools for actually then comparing the differences.
Yeah.
I guess once you figure out what it is, you can write a test case, and from there on, like most of
Yeah.
the job is done.
Yep.
Cool. I'm gonna need to run in a few minutes, so I don't know if there's no comments, and we're
comments.
like an hour and a half, so that should be plenty. We can do like another, maybe invite Tajin or somebody, and I can do another session at some point. But there doesn't seem to be any comments, so let's see. I don't know if you guys wanna like add something, but otherwise we can.
I think we can call it from my side.
Yep.
Cool. I learned a lot.
Right.
It's much clearer in my head how the whole thing works together and what are the limitations and pros and cons. So thanks a lot, mostly
Thank you.
to you, Folkley.
Thanks to you of setting this up. Like I
Nice.
probably wouldn't have started the video. So yeah.
Nice. Really happy. Cool.
Right.
Thank you guys. I'm gonna end the stream and see you soon.
Bye bye.